Hi guys, I am not here today, so we're going to be doing a little bit of a virtual kind of guided practice today. I'm pre-recording this. So for today, we're going to only be doing the guided practice and the independent practice. We're going to be doing the quiz at the beginning of next class instead of the end of this class. So if you have questions about proofs after we do all the practice today, you can make sure that you ask me at the start of next class before we do our quiz. But for the plan today, we're going to be doing the guided practice together on the board. You guys can go ahead and get out your packets and turn to the last page. We're going to be doing proofs together with the guided practice using this video. And then once the video is done, Mrs. Shanahan is going to pass out the independent practice, and you guys are going to be doing that by yourself. There is no answer key provided. You need to make sure you are doing it by yourself, and then you're going to turn it in to be collected at the end of class. If you have extra time, you guys should make sure that you are working on the spiral review, because that is going to be due next class on the 12th. So make sure you guys don't forget that due date is coming up. So again, for today, we're going to be doing the guided practice together, and then you guys will wrap up class with the independent practice, doing it yourself. Don't copy off of anybody else. It's really your time to practice to make sure that you know what you're doing. And then you will be turning that in to be collected. And then our quiz will be next class. So we're going to go ahead and get started. All right, so the way that proofs work is going to be very similar to what we were doing in our day 2 and day 3 lessons. It's just going to be a little bit more structured in how we represent the information. We're still trying to figure out if triangles are congruent or if parts of triangles are congruent. It's the same kind of stuff that we've been doing. So there are two different types of proofs. If you guys noticed in the lesson, I called them big picture proof and small picture proof. The big picture proofs are when you're trying to prove that the triangles overall are congruent to each other. And that's just what we've been doing all along in day 3 and day 2. Where you guys are either using side, 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 angle, 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 side, or HL to prove that the triangles are congruent. And this would require you guys to potentially add information or just use the information that's provided for you. The other type of proof is called a small picture proof, which is where you guys are being asked if angles or sides of triangles are congruent. What this proof entails is first proving that the triangles are congruent using one of the big 5 rules that we just talked about. And then after that, using a special rule called CPCTC, which stands for corresponding parts of congruent triangles are congruent, to then take the fact that the triangles are congruent to support your conclusion of parts of the triangles being congruent. So I'll point those out as we go along with the guided practice. So our first one here, we are given that these two triangles have been marked with the information that is in the given already. Okay? So they mentioned that A and D are right angles, so they put the little 90-degree markings in the corners for angle A and angle D, and they said that segment AB is congruent to segment DE. So they've already put the information into the triangles for us. So now what we're trying to prove is that these two triangles are congruent. So imagine this is a question you guys would have seen on day 2 or day 3, where all I'm asking you is, are the triangles congruent? If you were to approach it the same way that we've done for those 2 days where we practice over and over again, you would look at the picture first to decide whether you can add information. And if you look at this one right here, I know the one you guys see the fastest is the reflexive property. So I can say that this side is equal to itself using the reflexive property. Remember I told you on those 2 days that if you guys write down why you're able to add the markings, it'll make the proof process a lot easier. Well, this is what I was talking about. Because now with this side added here, the BE being congruent to itself, we can now say that the triangles are congruent by HL. Because they're both right triangles, the hypotenusa of each triangle is congruent, and then the corresponding legs of the triangles are congruent. That matches up with the HL rule to prove that the triangles are congruent. So if that's all I was asking is whether the triangles were congruent or not, this is where you would stop. But I ask you to write a proof. So what you're going to be doing is taking all the thinking that we just did, you're going to write it down in an organized fashion, and then the very last step is going to say that the two triangles are congruent by HL. So this is how you are going to organize the information. You're going to start with the given. abbreviate it a little bit using the symbol for angle because I can't fit all the words. So just like the other types of proofs we saw in Unit 3, you always start your proof off with the given or givens if there's more than one. So I have the A and D are right angles. I'm going to go ahead and then say that angle A, oh sorry, no, not that. I apologize, I was reading my key wrong. You're going to say that segment AB is congruent to segment DE, which is our second given. And so you write both of the givens up front. So we've written down what we knew already. The next thing you're going to add in is that new piece of information that we added in, the fact that BE is congruent to itself. Now what you have to be really careful about, remember I said I'm super picky about the way that you write the names of the segments. So you have to make sure that when you write the name of the segment, it's spelled correctly when you guys write the congruency statement. So if I take segment BE, and I say that it's congruent to itself, you have to be really careful that you're naming it correctly. If I name it BE in that order, go from B to E, if I'm going to name it in the same order, in the other triangle, I have to call it EB. Now you may be asking yourself, how am I supposed to know when I write it in the same order or in reverse order? Well, it's a really good way that you guys can check, and it's by looking up here. So if you notice in the name of the triangle, it was ABE where the B was first, and then in the second triangle it's DEB where the E is first. So if you're unsure about what order to use for those letters, you can just look at the name of the triangle to figure out how they do it, and then you can copy that down in your congruency statement. And then remember, we knew this because of the reflexive property. You guys can either write reflexive property all out or just write reflexive, that's fine with me. And so that is our reason for those two segments being congruent. And then with those three pieces of information, that's all we needed to prove that triangle ABE was congruent to triangle DEB. And that was by the hypotenuse leg rule. So this is how you write a proof, just taking the thought process that we've done on day 2 and day 3 and writing it out in a structured format like this. So that's really all there is to writing proofs. So this one was 4 lines. Sometimes you guys will notice I give you an extra line there, because sometimes when people write proofs, they go in a different direction. And I just like for you guys to have the freedom to potentially do that. So that's why I usually give a line or 2 extra just in case. But for this one, it was really cut and dry, kind of the direction you would go in with that. Alright, so let's look at the second one. For this one, they've also put the markings in for us already for the given. So they said that BC was congruent to DA, and then they said that angle CBD was congruent to angle ADB. Okay, so they have that information already. So let's go ahead and add that into our proof. So both of these were given. Alright, that should be the easiest part. They already gave it to you, so you just need to write it down and say that the reason you know this information is because it was given to you. You don't need any other support for that. So now, again, go back to that question that we would have seen on day 2 and day 3. If you're just looking at the picture here, and I want to know if the triangles are congruent, how would you show that? How do you prove to me that they're congruent? Well, this involves adding information and then determining which of the big 5 rules would prove that they're congruent. So if you look again, I can add the information right here for that segment. I can use the reflexive property to say that that segment is congruent to itself. And then with that information, if you look at each triangle, I have side equals side, side equals side. So these two would be congruent by side equals side. And remember, you guys can use that color coding I taught you, where you can color these sides in one color and the angles in another, and that's how you can see that the angles are between the two sides, and that's how you get the side equal side. So with the 2 pieces of information I already had, I have to add that other piece of information that BD is congruent to itself. So again, I'm going to go ahead and write that down on my next line. And then you can stop and check the way that they ordered the lettering in the name of the triangle. They go BD and then DB. they did switch the order. And that was the reflexive property. And then with those three pieces of information, I know that the two triangles are congruent by side equals side. So B, triangle BCD is congruent to triangle DAB by side equals. Alright, so again, it's just our thought process from past lessons, just written out in a more structured format. So here's our next one here. I know that angle B is congruent to angle Y, and then I know that WZ bisects angle BWY. So that they haven't put into the picture as a marking, so we're going to be responsible for doing that ourselves. Let's go ahead and write down the givens first, and then we'll think about where we go from there. So I know that angle B is congruent to angle Y. Excuse me. And then segment WZ bisects. I gotta write small line. Alright, so now from here, we gotta figure out what this bisect idea means. So the directions are very clear that this segment right here is going to bisect this angle. So you guys have to remember what bisect means. It means to cut in half. So if this segment is cutting the angle in half, that means I have two congruent halves to add into my picture. So I'm going to go ahead and clear this away. I'm just going to make it a little bit neater so I already knew that these were equal. And then with the bisect idea, I can now say that these two angles are equal as well. Okay? So that's where the bisect comes into play here. So that would be our next line in the proof. If I told you that something was being bisected, and then from that you came up with a new conclusion, that conclusion needs to go into the proof. So the fact that we have the bisect led us to say that these two angles up here are congruent. So I'm going to write that as the next line. Angle EWZ is congruent to YWZ. Again, make sure you guys name them in the correct order. I went clockwise, starting at B up to W to Z. So Z and Y correspond because of the theme up here. So again, you can use the name of the triangle to make sure that you name it correctly. Now, if you remember, when you guys use vocabulary words to create a conclusion in your diagram, that's when you guys use the definition of that vocabulary word. So because I saw the word bisect, and then my understanding of that vocabulary word prompted me to say that I had two congruent halves, so I was using the definition of bisect to create a conclusion. The same way that you guys would use midpoint or perpendicular or anything like that. That would be your reason in the proof. Alright, so that's everything that we have from the given. Now let's see if we can add more information. If I was looking at this picture and I still wanted to see if I could add anything, remember those reasons you need to go through in your brain. If there's reflexive property, if there are vertical angles, if there are parallel lines that could give us congruent angles like alternate, interior, or corresponding. If I have isosceles triangle here, if I have perpendicular going on, any one of those things you need to consider. So there are a couple of different ways you can go with this proof. Again, that's why I give extra lines in case you guys go in a different direction. So I'm going to go in the direction I feel like most of you guys would catch first, which is the fact that we have another reflexive property right here. I'll talk about the other way briefly, but I'm not going to go too in-depth. So I know that that segment is congruent to itself using the reflexive property, so I can add that into my proof. Let me scoot down a little bit. So I can say that WZ is congruent this time. I don't have to switch the order. And again, you can look up at the name of the triangles to see why. I don't have to switch the order there. Because W corresponds to W and Z corresponds to Z, so you don't have to do that weird switch up. And that again is the reflexive property. With that information, if you take a look at each triangle, I have two angles and a side in each triangle, and the side is not between the two angles. So that is the angle, side rule. Hopefully you guys can see that. Angle, side in both triangles. And they all correspond and work together like that. So then I can finish my proof with triangle BWZ being congruent to triangle YWZ. And that is using angle equal sign. Now, the other way that you guys could have gone with this proof, and it's totally up to you, both of the proofs would be acceptable. You could also notice that the full triangle VWY, you could use the isosceles property because you have two congruent angles. These two angles are congruent, so if you have two congruent base angles, you could say that you have two congruent sides. So you guys could have also gone in the direction of angle side angle if you chose to use the base angles theorem. Alright, now we're going to look at this last one here. So this one has parallel lines, so for these ones you have to make sure that you're being extra careful when we're working with parallel lines. So they've already marked them for us. We know that these lines are parallel right here. We also know that they are congruent. Just because they're parallel doesn't mean that they're congruent. Be careful with that. They've just given us that they happen to have that relation, both of those relationships at the same time. And we also know that angle E is congruent to angle D. So these are all the givens. So we're going to go ahead and write those down. So I'm going to start with parallel, and then the congruency, and then the angles being congruent. So we're just going to write down all of the givens. Alright, now once you have all the information that you already know written down, we're going to see if there's anything that we can add. So if you take a look at the picture, whenever you guys have parallel lines, remember that parallel lines give you angles. So the two pairs of angles that you guys will see in these kinds of pictures are either going to be alternate interior angles or your corresponding angles. So you want to look really carefully at this picture. The parallel lines are these guys right here. There are two options for a transversal in this picture. You could use EB, the diagonal line here, or you could use AC, which is that horizontal line. If you use EB, you could technically get alternate interior angles, but one of the angles would be outside of the triangles, and that's really not helpful. So the transversal you're going to use is this one instead. So this is a situation where you guys will get corresponding angles being congruent. Remember, it could be either alternate interior or corresponding, so make sure you guys are looking for either. So the angles that would be congruent using corresponding would be these guys right here. Okay? Excuse me. So now, with the parallel lines, I can say that angle EAB is congruent to angle DBC. I was being really careful to make sure I name them in the same order. EAB, DBC. So again, make sure you guys are doing that yourself. So the reason why these angles are congruent, again, is because corresponding angles are congruent with parallel lines. So you guys can abbreviate that however you want to. You can use the name of the postulate that says that, as long as you guys are explaining that reasoning to me in your proof. So I'm going to go ahead and say corresponding angles are congruent with parallel lines. But again, you guys can, you could use the corresponding angles postulate as another way to explain that. That's the name of the postulate, or you could use the wording of the postulate, which I did right here. Either way, as long as you guys are expressing to me the reason why, you can say that those angles are congruent, you guys will be fine. One of those two ways. Alright, so now that I have my givens, which was the segment that's congruent and the angle that's congruent, when I add this angle right here, I notice I have angle, side, angle, angle, side, angle in each triangle. So I can say that the triangles are congruent by angle, side, angle. So, triangle AEB is congruent to triangle BDC. Oops, that was weird. There we go. Alright, so again, make sure you guys are really careful to catch the angle pairs that you can see with the parallel lines. Alright, so we have a couple more on the next page. Alright, so for this one, again, they have already provided given information for us. So we know that ABC is congruent to CBD, so these triangles right here are congruent. We also know that BDA is congruent to BDC. So I have these two sets of congruent angles that are provided for us. And this is a small picture proof. Everything on the previous page, the front side, those were big picture proofs. So I was just proving that the triangles were congruent. I think all the proofs on this side of the paper are small picture proofs, where you guys are trying to prove that parts of the triangles are congruent. Before you can say that, you first have to prove the triangles are congruent. So you're going to be doing the proof style from the front side of the page, and then you're going to add one extra line, which is to say that these segments are congruent using the CBCTC rule, that corresponding parts of congruent triangles are congruent. Again, to prove that corresponding parts are congruent, you first need to have that the triangles are congruent. Okay? So we're going to prove the triangles are congruent first, just like we did on the first page, and then stick one extra line on there with the CBCTC, just like you guys would have in the notes. All right, so taking a look, let's go ahead and put our givens in real quick. The first set of angles, and then our second set of angles. Alright, so I have two pairs of angles in each triangle that are corresponding and congruent. So again, if I was just asking you up front, are the triangles congruent, you would go through that thought process just like on days 2 and 3 to see if you could add any information and then decide which of our 5 rules would work. So again, I think the easiest one that you guys are noticing is that reflexive property. So I can say that that middle line, the line that the two triangles are sharing, is congruent to itself. That's a reflexive property. So I can go ahead and write it down. Now this is where you guys have a little bit of a crutch. On the previous page, when we had reflexive property, we were using the names of the triangles to decide how to organize the letters so they were in the same order. You can't do that here because they haven't named the triangles. So this one, you're going to have to figure it out on your own to decide what the order should be. If I'm looking at the triangle here, I notice that B corresponds to B in the way that the angles are named, and that D corresponds to D there as well. So you don't just have to use the names of the triangles, you can also use the names of the angles and the segments to figure out the order as well. So because I can see that they're written in the same order in the organization of the angles, I can go ahead and write them, the angle, in the same order here as well. So BD, I don't know what my D was so funny. There we go. BD is congruent to BD, that is the reflexive property. Alright, so now if you're looking at the triangles, we've pretty much proven that the triangles are congruent. We have two angles on the side, each triangle or the sides in between. So I can say that the triangles are congruent by angle, side, angle. Now this is where it's your choice how you would like to name the angles. So you're going to, the triangles. You're going to name the first triangle however you want. Just make sure you name the second triangle in the corresponding order. So if I name the first triangle ABD, then I'm going to name the second triangle. So I check really quickly what corresponds to A, that would be C. What corresponds to B, that would be B itself. And then what corresponds to D would be D itself as well. So you can name the first triangle however you want. Just make sure you name the second triangle in the same order. And then again, the reason why I know the triangles are congruent is angle side angle. Once you've gotten here, this would be the end of a big picture proof. If I just wanted to know that the triangles were congruent, that's where you would stop. But because this is a small picture proof, you just have to stick one extra line on there. You have to always finish with what we're trying to prove. So I'm going to say that segment AB is congruent to segment CB using the CPCTC rule. Okay. Again, this is dependent on this. You first show that the triangles are congruent. That's what that's what these two stand for, congruent triangles. So once you prove that the triangles are congruent, then you can say that the parts of the triangles are congruent, which gives us our last step. So there's really only one extra step when it's a small picture proof, and it's quite simple to make sure you write that down. Alright, next one. I know that OM is congruent to ER. I know that ME is congruent to RO. And then I'm trying to prove that M is congruent to R. Again, another small picture proof. In order to prove that the parts of the triangles are congruent, I have to prove that the entire triangles are congruent. So I need to figure out which rule of our 5 rules I can use to do that. So first I'm going to write down my givens. Alright. Now we need to think, how can I add information to the picture in order to find one of the 5 rules to prove that they're congruent? And so the only thing I can do is the reflexive property. I can say that middle line there, the one that they're sharing, is equal to itself. That's using the reflexive property. And so again, I'm going to have to be really careful that I name everything in the correct order. If I look at the names of the segments, I can see that O corresponds to E and E corresponds to O. So that means that when I write the name, I will have to switch the order. So I call it OE is congruent to EO. Alright, because O and E, they kind of switch roles depending on which triangle you're working with. So in one triangle, it would be called OE, and then the other one is called EO, in order to get the corresponding parts to match. And that is the reflexive property. And again, the way I knew that O corresponded to E was just by looking at the name up there to see if they corresponded. Alright, so with this information, I have 3 sides for each triangle, all corresponding, all congruent. So that's the side rule. So that's how I know that these triangles are congruent. So I'm going to call the first triangle, let's call it MO. Triangle MOE. If I call the first triangle MOE, I have to name the second triangle REO. Because again, you have to match corresponding parts. You have to match corresponding parts. So the M and the R correspond, and then just like we were talking about a second ago, the O and the E correspond. That's how I knew to write the names of the triangles, and they're congruent by side. And then lastly, again, because this is a small picture proof, I want to make sure I finish with the corresponding parts of these triangles being congruent by the CPCTC rule. Corresponding parts of congruent triangles are congruent. Alright, 2 more. Alright, so this one I have SPT is congruent to OPT, so they have that marked already, it's just a little bit small, so I'm going to go ahead and make the markings a little bit bigger here. And then they also told us that segment SP is congruent to segment OP. So again, this is a small picture proof, so first I need to show that the full triangles are congruent, and then I can use CPCTC to prove that the individual parts are congruent. First I'm going to write down the givens, just like you would for any proof. Then again, just like on day 2 and day 3, we look at the picture, decide if we can add any information that would prove that the triangles are congruent, and then we decide which rule applies. So looking here, I can see that the reflexive property works again. You guys use the reflexive property the most, I think. Vertical angles and parallel lines are probably the second most common that you guys would use. Reflexive, I feel like, is probably the most common one you will see. And so when I add that line, again, you have to make sure that you write that down. Any markings you put into the picture, you have to make sure you write down as a step in the proof. So when you use a reflexive property, I need to say that that segment is equal to itself. So I say that segment TP is congruent to segment TP. And the reason why I know this is, again, I look up here, my evidence, I notice, oops, I just wrote over it. I noticed that in the way I named these segments, that P corresponded to itself. So that means that I can have it correspond to itself in the name of TP as well. So again, you guys can get these hints from the givens when you guys are working through the proof. So again, that's the reflexive property. Alright, once I have all that information, I take a look at all my markings. I can see that the 2 triangles are congruent by side, angle, side. So they have 2 sides and an angle in each triangle. The angle is in between the 2 sides. So I'm going to say that triangle STP is congruent to triangle OT. Be careful to make sure everything that's corresponding is aligned in the way that you spell the triangles. And that is using the side angle side rule. And then because it's a small picture proof, my last step is going to be that the corresponding parts of the congruent triangle are congruent, the CPCTC. Alright, our last proof is another small picture proof to wrap up this set of examples. So I have a lot of given here. So I have segments YT and YP being congruent. I have angle C is congruent to angle R. I have angle T is congruent to angle P. And I'm trying to prove that segment ET is congruent to segment RT. So I'm going to go ahead and write all the givens just to start. Alright, so with these three pieces of information, what's really interesting about this proof is that when you guys are looking at the picture here, I could add information, but I don't need to. You guys could say, if you really wanted to, you could say that these two green angles are congruent because vertical angles are congruent. You could definitely add that. But that would be superfluous. You would get the correct answer for your proof and proving that the triangles are congruent. And it would be totally valid, but it would be longer than you would need it to be, and it would just kind of muddle up your proof. So if you look really carefully at what's going on in each of these triangles, they've actually given us everything that we need to know up front. I have two angles on the side over here, and then I have two angles on the side over here. I have corresponding congruent parts, two angles and a side knot between them already set up in the triangle. So actually, I can hold two angle side automatically. I don't need to add anything. If you did add the vertical angles, it's totally fine. You could add the vertical angles and say that it's congruent by angle side still if you wanted to. Or you could also switch it to angle side angle. But you don't have to. Again, that would just make your proof a little bit longer, a little messy. But it would still be accurate. But because this one already gave us everything covered, I'm not going to mess with it. I'm just going to go straight to the triangles being congruent. I'm going to call the first one TCY. And then based on that name, I'm going to call the second one, is that a P? PRY. Let me just check. Yeah. So C and R correspond and Y correspond to itself. So everything is correct in the way that I organized those letters. And the triangles are congruent by angle side. By the way, when you guys are writing your own proofs, obviously this line right here is going to be different for everybody. Because if you name the first triangle differently than I do, your second triangle is going to be named slightly differently. That's okay, as long as you guys, with the way that you write it, everything's lined up appropriately. You can do it however you want. There are a couple different ways you can write it, as long as it's written in the correct order. It doesn't matter whether you use my order or not. And then lastly, because this is a small picture proof, I will finish with my proof statement. And CPCTC is the reason why I can say those two segments are congruent. Alright, so we have finished the guided practice, so now you guys will be finishing class by doing the independent practice. So Mrs. Shanahan is going to pass out those papers for everybody. You guys will complete it, make sure your name is on it. You should be doing it independently by yourself. And then once you guys are done, you can go ahead and bring it to turn it in to the black tray. And I will be looking at those when I come back. Just a reminder, the quiz will be pushed until the beginning of next class. The next class is our review. So we're going to have review for all the lessons from this unit. But before we do that, I will take any questions that you guys had about the proofs lesson and the math space practice. And then we'll do the quiz to get that out of the way. It will be a little bit longer of a quiz just because proofs take a little bit more space on the paper. I think it's about 2 to 3 proofs that are on the quiz. They're going to look just like these. You just have to be able to look at it to know whether it's a small picture proof or a big picture proof. But again, it'll look really similar to your guided practice and your individual practice. So make sure you guys take those seriously. and we'll do that at the start of class, and then the remainder of next class on Tuesday will be our review for our tests, and then we will be testing on Thursday. So make sure you guys have all of your math space lesson checks done. Remember, you have 2 days after the due date to do them, otherwise they're cut off and you're not going to have access to them. So make sure that you're doing them on time or taking advantage of that 2-day extension for partial credit. And then make sure you guys are ready to turn in your spiral review on the 12th, which is the due date. The 12th is going to be our review day. So yeah, that same day that you guys come back, that we're going to be doing the quiz for proofs, that is when the spiral review is due. So make sure that you guys take any time that's left over today after you finish the independent practice to do the spiral review or work on it at home to make sure it's ready to be turned in on Tuesday.